Hello, everyone, and welcome. My name is Jessica Williams, and I'm the Programs and Community Partnerships Manager at Chabot Space and Science Center. And we are thrilled to bring you another exciting programs to your homes this evening. We are in partnership with this program is in partnership with the SETI Institute. And tonight we have with us Dan Peluso, who will tell us about his work in citizen science, astronomy for classrooms. We are so excited to bring you this talk in partnership with the SETI Institute, and we have Simon Steele to tell us a few words, and thank you so much for joining us.
Thank you, Jessica. It's wonderful to be here again for what is the 8th, and I had to count, joint SETI Institute and Chabot Space and Science Center Talks for Families. So welcome, good evening, everyone. For those of you who haven't joined us before, the SETI Institute is a research institute across the Bay. We're a nonprofit, just as Chabot is, and our primary focus is to search for life in the universe for all its forms, everything from little microbes on Mars to alien civilizations. So if you want to find out more about the SETI Institute, please do go to our website, www.seti.org. Likewise, if you want to watch the talks that you've missed, all the back catalog of 7, they are on both the Chabot YouTube channel and on the SETI Institute YouTube channel. Please do go back and look at all those exciting talks. Thank you, Jessica, for hosting again tonight. In the background, there is Lee. Thank you, Lee, for doing the technical stuff to keep us on air. And welcome and good evening, Dan. We look forward to your talk. And without further ado, I'm going to hand back to Jessica.
Thank you, Simon, and thank you to the SETI Institute. I really can't believe it's already been 8. That's exciting. And we have many more to come, hopefully in the future. And it's just been a really wonderful opportunity to work with you all and to hear some great speakers. But now I would like to introduce to you all Dan Peluso. Dan is an astrophysics PhD candidate with the University of Southern Queensland, studying and researching remotely from the Bay Area, California, and is also a Unistellar Education Associate and researcher with the SETI Institute. Peluso's PhD project is a multidisciplinary focusing on NASA TESS exoplanet follow-ups, astroseismology, and astronomy research, education research. For the astronomy education and SETI research, Peluso is developing a global exoplanet citizen science network for education using unistellar enhanced vision telescopes, EVscopes, so that teachers and students can observe exoplanets and learn science by doing science. Peluso has years of experience as a high school science teacher and hopes to connect with educators and students from diverse and underserved backgrounds to build his network. Peluso also enjoys photography, music, film, and is an active singer, songwriter, and musician. And you can check out his most recent music project, Falling Andes, on Spotify and Apple Music, but he's excited to share that he's currently working on a brand new music project under the artist name Connor Phoenix for release in mid-2021. And also, we will take questions from the audience during this talk, so please be sure to post your questions in the chat so we can get to that in the end of the Q&A session. Dan, thank you so much for joining us. It's a pleasure to have you.
Thank you so much, Jessica, and thank you, Simon and Lee, and everyone who's tuning in. All right, so I'm going to go ahead and share my screen and get started. All right, so we're
Looks like we lost some audio.
And we're also going to talk about exoplanets because that's actually something that I'm focusing on in my PhD and something I'd like students to get involved with because they find it pretty exciting, and I'll tell you why once we get there. And also how you can get involved at home. So as Jessica mentioned, I am working on a PhD with an Australian university, University of Southern Queensland, but I'm based in the Bay Area, California. And I want to bring space and astronomy to classrooms across the world, K through 12, and also junior colleges and informal education places like the Science Center. And I also hope to improve science education in some ways. As Jessica mentioned, I was a high school science teacher, and I have some thoughts and ideas of how I'd like to improve science education, make it more exciting for kids. Now, I have a question for the audience, and this is something if you can, I guess, add to the chat, or just think about it if you don't want to add to it, is what makes someone successful in today's modern world? So think about that or add it to the chat. We're going to come back to that later. What makes someone successful in today's modern world? All right. So how do astronomers study the universe? It's a science built from light. We look up at the stars and we study the cosmos. We don't have any earthbound labs like our science colleagues do. We observe. It's an observational science. And we do this using telescopes. So how do telescopes work? Well, a great analogy that's used often is the idea of a bucket filling up with rainwater, where rain is analogical to light. In the bucket, the telescope. The bigger the bucket, the more rain you collect, the more light you collect. The farther away you can see, the more things that you can see. And there's some two basic types of telescopes on the screen here. And we have optical telescopes of refracting and reflecting. There's some other ones, but those are the two main types. And they usually have a mirror which focuses light, and then you can see things that are farther away. It's like that bucket of light. Now, one thing that has allowed astronomy to excel in modern times is the same kind of technology you have in your phones. So if you pick up your smartphone and take a picture, you're actually collecting light, just like an astronomer collects light. And advanced telescopes also do this. They use these digital light detectors, some called CCDs or CMOS cameras, and it allows us to take long exposures, helps us to save data and images of the sky and collect different types of light. If you're a photographer, or if you've ever explored photography or thought about it, there's something that photographers use called an exposure. And when you set the exposure, that allows you to collect more light on your camera. And you can do some pretty creative things. For example, you can create light art where you do a long exposure and you have someone draw light with like a flashlight or some other kind of light source. But you can also get really cool pictures of cities with traffic driving by. And if you take a long exposure of the water, then you can see the water kind of flowing together and smearing together to create these artistic looking photos. Now, if we think about a telescope, a backyard telescope that you might have experienced, those traditionally don't have any kind of light detector in them. They're just the optics, just the lenses and the mirrors. So you don't have that ability to take long exposures. And one thing that we also come into issues with doing astronomy here on Earth is light pollution. So all those lights that light up our night skies and make our cities look nice and pretty and fun, those are not good for astronomy because they reflect off the atmosphere and they blind us from the cosmos. And there's some examples of light pollution in some of these pictures. It's increasing dramatically. I think I heard once that something like 85% of the world has never seen the Milky Way galaxy because of light pollution. There's a fun story in the 90s where there was a blackout and all of the lights went out in Los Angeles and people called 911 reporting a strange gas in the sky. And it wasn't anything to be afraid of. They were just seeing the universe for the first time. But that also, that constricts us or restricts us from being able to see the universe as we'd really like to. So sometimes we put telescopes in space, and you've probably heard of the Hubble Space Telescope before. If you haven't, it's a school bus sized telescope orbiting around planet Earth right now. It's pretty amazing. Pretty good chances if you've looked up some astronomy pictures on Google, you've seen a picture that the Hubble Space Telescope has taken. The Hubble Space Telescope has a light detector in it, just like I mentioned earlier. And I want to tell you about a really cool picture that it took using a long exposure. It stared at this really tiny spot of the sky. And this was an idea that was thought of from the director, Robert Williams, I believe it was his name, and he decided to look at what looked like an empty spot in the sky. And some people thought it was a silly idea just to look at some small blank spot of the sky. In fact, it was so small, if you were to hold a pin at arm's length up in the sky. That was a larger area than what the Hubble Space Telescope looked at in 1995 when it took this this picture. And what happened is, after a 10-day exposure, just like the exposures in your cameras I talked about earlier, you saw all of these objects and strange blobs and dots on the sky. And basically every dot you see and blob, except for some of the stars, which are foreground stars of our own galaxy that we're looking through, is a galaxy. This is called the Hubble Deep Field. And this is amazing because this is showing us that basically a tiny little pinhead spot in the sky is full of galaxies. And from that, we can then determine that we are in this universe amongst billions and billions, hundreds of billions of other galaxies. It's an amazing thing just from being able to do an exposure in the sky. So in the classroom, if you're a student, or when you were a student, if you think back to that, you might have had access to a telescope. I know I didn't. Whenever I was in school, there was no telescopes for me to use. Some people get to, but many don't. But I definitely had one of these telescopes that you see in the picture. So your general backyard telescope. Some of you might have one. Maybe you have one. It's in your garage or in your basement collecting dust because you couldn't figure out how to use it or point it at things. You got frustrated, or maybe you didn't even know you had it. So maybe you do have one of these. They're very hard to use. They're great. They're great to learn on too, but some people can get frustrated with them. And one thing that's difficult is you can't save data for these. You can't do those long exposures to see deep space objects. So you can't see as far. They're not good in light pollution. And they're great for the solar system. So you can look at, you can look at the moon, you can look at the moons of Jupiter and Saturn, and see some of the planets, but you can't see deep space objects. So it gives us kind of some limitations for how they could be used in the classroom setting. So a lot of astronomers realize this, and for decades have been trying to develop programs so that schools could access research grade telescopes. And some of these include some remote robotic telescopes that anyone can access for free. And some of the most popular ones include the Las Cumbres Observatory, or LCO. There's also the Harvard Micro Observatory. One of the first ones actually was the RAAP, and I can't remember what that stands for, but it was at UC Santa Barbara. Other ones include iTelescope.net and the Goldstone Apple Valley Radio Telescope, which is a NASA 40-meter radio dish where you can look at the radio signals coming from galaxies and in our own. But there's a whole slew of these, and the great thing is they're free, they're accessible to everybody. You can view and schedule during the day, and maybe if you're in a classroom during the daytime and you want to observe, well, you can't because it's daytime. So you can actually access telescopes that are on the other side of the planet and be able to view the cosmos. And I believe there are some links that I have that Jessica is going to be adding either during the talk or afterwards, that will have links to, so you can actually go to these. So if you're a teacher or you're a student or you're just general public, you want to see how you can access some of these cool images, feel free to check some of these out. I highly encourage it. There's also this program through Global Hands-on Universe, which is GHOU, which is trying to connect teachers and students to actual research grade data and teach students how to do astronomy data in the classroom. So these are great things out there. Some of the disadvantages, though, you can't always schedule when you want. It's harder to do citizen science projects that are time dependent, such as with exoplanets. And you don't have as much ownership as having your own telescope. But these are great programs nonetheless, and I encourage you to check them out. So something that I'm very intimately involved with is this new consumer telescope called the Unistellar Enhanced Vision Telescope that Jessica mentioned. And this is a new telescope that is available for the public to purchase. Just like you go anywhere to buy a telescope, you can now buy one of these telescopes. And the great thing about this, it's really easy to use. It runs off an app. It has its own app, and it's completely digital, that you can just control it with the touch of a finger. And How it works is it has a live projection system that projects the images that you're seeing from a sensor that's collecting light. So remember we talked about cameras and long exposures and how the Hubble Space Telescope had a digital detector so it could collect a long exposure. You can't get Hubble quality pictures with this, but still you can take long exposures with this telescope and see deep space objects. Recall that more light you can see farther. So if you're able to take a long exposure, you can see farther in the sky. And the goal of Unistellar, which is the company that makes this, they're a company in France, and they actually work with the SETI Institute in order to develop science and education opportunities, which is why I'm here, is to make enjoyable observational astronomy, make it accessible to more people and easier to use, and also get people involved in something called citizen science, which I'm going to tell you about in a little bit. So this is some pictures of the app, and it allows you to actually control the telescope with a joystick and pick objects just by clicking on the ones that are recommended to you based off your location. And then there's these science modes where you can actually look for certain types of scientific events, which I'm going to tell you about as well. And it also allows you to save your pictures so you can share them with your friends or other students or your students if you're a teacher. And it allows you to upload and download your data as well. This is an example of what you would see looking at a star cluster with a normal telescope, just with your lenses and mirrors with no digital detector to save it and to expose it. This is an actual image by the EVscope using its powerful enhanced vision technology. So what it does is it takes a long exposure. When you press this button right here with the eyeball, it's called enhanced vision. And when you press that button, it starts taking some exposures of the sky, and it uses this fancy algorithm to stack those images and create the beautiful pictures that you see of the night sky, taking those exposures like an astrophotographer would. But it all does it for you, so you don't have to think about it. It just does it automatically. These are some images that I took, and I took these recently in the light polluted city that I live in Vallejo, California. So this is about 30 miles or 48 kilometers if you're on the metric system, north of San Francisco, California. So pretty amazing that I'm able to see some galaxies. So you can see the spirals of a galaxy in this picture in the upper left. I can see star clusters. I can see ring nebula, other nebulas, and other clusters from a light polluted area. Now, if I go to a dark sky, somewhere away from light polluted cities, I can see things like this. So this is I'm going to show you a couple images that were taken with the Unistellar EVscope in dark skies. Now, I think these images were processed a little bit using Photoshop or Lightroom or some sort of photo editing programs, which a lot of astrophotographers do with their images anyways. But this is pretty amazing that this little telescope, by the way, it's tiny and it fits in a backpack. In fact, if you can see the video, I have mine right here. So it actually fits in a backpack. And whenever I'm not doing my slides, if there's time, I'll show you this on the full screen. But I can just put this on my backpack and go somewhere, take the telescope out, set it up, and start doing some astronomy with it. Some other pictures that were taken by some Unistellar users. It's the fireworks galaxy. Here's another galaxy. Another one. All right, so some cool stuff that you can do with the Unistellar EVscope. And what I want to do is switch gears and tell you a little bit about exoplanets and how I'd like to use this Unistellar EVscope in the classroom. So first off, what's an exoplanet? Exoplanets are just planets around other stars. So how do we find these? How do we know that these exist? Well, people have thought that there might be planets around other stars for hundreds of years. In fact, hundreds and hundreds of years ago, some people said, oh, there's probably planets around other stars, and people thought those people were a little bonkers. But it turns out they were right. And how do we know that they're right? Well, we use observational science of astronomy and telescopes to point at a star. And the problem is that stars are very bright. Planets are really tiny compared to their stars. So a really good analogy to think about is think about a fly or a small bug flying across a spotlight. Think about the spotlight at the Grammy Awards or your award show, and a little fly just flying in front of that spotlight. If you were to be able to collect the energy from that spotlight and then compare the energy from the spotlight without a fly flying across it to the energy of the light from that spotlight when a fly is crossing in front of it, you would see that that energy might be a little bit less. And that's exactly what we're doing when we're finding exoplanets. We're looking at a star and we're looking for something called a transit. And what's a transit? Well, let's think about something in our solar system. We have the planets in our solar system that we can use to think about how other solar systems might be. And this is the transit of Mercury, which was taken with a NASA telescope back in November 2019. And a transit is when a planet passes in front of its star that it orbits around from the observer's perspective. So if I were to take a telescope and point it at a star and see that dip in light over time, then we would call that a planetary transit. The observer, basically the person looking with the telescope, sees a shadow of the planet. And astronomers create these things called transit light curves. And that's what this is in the lower right-hand corner. That's called a transit light curve. This is our brightness on the vertical axis here, and then time on our horizontal axis. And what we look for is for that brightness to dip over time. And if that happens, that could mean that there's a planet passing in front of it. And what astronomers and engineers did is they created some amazing telescopes to put in space to get past the light pollution and the other problems of doing astronomy on Earth to try to find these. And one of the most successful here was Kepler, found thousands of planets. And right now there is a telescope orbiting around Earth called TESS, the Transiting Exoplanet Survey Satellite, which is currently looking for exoplanets. I'm actually involved a little bit in that research. So what have astronomers found so far? They've found gas giants, giant gas planets similar to Jupiter, Saturn, Neptune-like planets. They found super Earths, so rocky terrestrial worlds that are 2 or 3 times larger than Earth. They've even found planets like Earth, I guess you could say that, similar in size and density. And it's an exciting thing is, could there be another planet that is like Earth out there that could have water and could have life? They're exciting things to think about. Now, what we know from the abundance of exoplanets that have been found so far is that on average, every star in our galaxy has at least one exoplanet, at least one, probably a lot more than that, but at least one. Now think about that the next time you go out and look at the stars. Look up and you see some stars in the sky, some dots of light. Just take a second and think about that. That star that you're looking at has a planet around it. And that's a pretty amazing thing to think about. And I know the SETI Institute, the Search for Extraterrestrial Intelligence, we're always thinking about, well, could there be intelligent life out there trying to communicate to us or communicate to others to let their existence be known? So you could look at those stars at night and think, I know a lot of astronomers have said this before, but it always makes the hair on my neck stand up, is look up at that star and think, is there another life form looking at a star on their planet, thinking the same thing? Does that star have a planet with life on it? Are we doing it at the same time? It's an amazing thing to think of. And that excites a lot of scientists that work in this field. And I know as a teacher, when I was teaching, that this excited students a lot. So astronomy in school, every time I've talked about it, I was a physics teacher. And anytime I brought up astronomy and the idea of life, students got very, very excited. But most high schools don't have any astronomy classes. In elementary school and middle school, there's some astronomy built into a lot of the curriculum and the lessons that you get. Then in high school, some students get it in earth science or their physics class. But generally, in high school, you're going to take what? You're going to take biology, chemistry, maybe anatomy, physics, some people actually have a choice to take physics, your earth science, environmental science, but, it's very rare to be able to actually have the ability to take an astronomy class in high school. Now, some do, and that's great, but not everyone gets that chance. There are a lot of after-school programs that happen in schools for astronomy, clubs and schools and students that are excited about it get involved in that way. This is such a humbling and multidisciplinary field. I mean, astronomers, physicists, geologists, engineers, there's a lot of different fields that work in astronomy, and especially in astrobiology. I know there's tons of talks with SETI of astrobiology, how multidisciplinary it is, and how exciting it is to think about life elsewhere. The fact that we live on this planet that is our only home that we have to take care of, in this deep abyss of space. So why don't we study it more in school? Why isn't it more prevalent? People get so excited to talk about it. Well, how come it doesn't happen more? I am not 100% sure why, but I have some ideas. Well, some ideas of why we might not do it is because it happens at night and school happens during the day. So, that's pretty obvious. If you've ever been in a science class, you have to do labs and you collect data and try to understand that data and analyze it, go through the scientific process. And it's kind of hard to do that when school's during the day, and getting out at night is, not something that, most schools can do, or students even want to do, or even teachers want to do. So it's an observational science, observational astronomy. You have to have elaborate technical setups. You have to have a telescope with a detector to save it and collect the data. You can't do that with your average telescope with just a lens and a mirror. Most people aren't going to be able to set it up in order to collect the data. A lot of teachers probably not know how to connect astronomy to their core high school science class. A lot of them do, and they do an awesome job. But I know a lot of teachers teach subjects that they're not, that they don't have a background in. That's just the state of the education system. Is that we're often, as teachers, we're having to ask to teach classes that we don't have an expertise in. Data for labs. So you need that detector. It's also not well integrated into education standards in most states. It's there in some places, especially in earth science and some in physics, but it's not as well integrated as as a strong enthusiast, as I think it should. I want to come back to this question now. So I asked you at the beginning, what makes someone successful in today's modern world? So think back to what you said or what you wrote. And I wanted to read a quote from somebody who has an idea of what might make somebody successful in today's modern world. This is someone named Dr. Yang Zhao, and he's a pretty well-known education reformer for creativity in the classroom and project-based learning. And what he says is that what makes someone successful in the 21st century is definitely not your ability to memorize facts. What's going to make someone successful is your relentless capacity to innovate and to create. It's your ability to network, to make friends from your own circle and from other countries. It's your ability to see through challenges, to look for opportunities in problems, and to take action to change things instead of waiting for someone else to do something. So being proactive. So think about that. And I want to tell you about a dream that I had. This is a dream I had last year when we had a pretty bad thunderstorm in the Bay Area. And I remember waking up to lightning strikes, and I remember the dream that I had. And in this dream, I think I was in my chemistry class. This is me in the hoodie here. And my group was asked to go to the board and put the correct answer down to the problem. And we didn't know the correct answer, and everybody laughed at us, including this favorite character from The Simpsons. And it's because of this that made me think about how we do science education and how we do education in general. We focus on the answer. And science is about the process. Think about the kid jumping in a puddle. Don't jump in that puddle. Don't Don't play in the dirt. Don't get your hands dirty. Why is the sky blue? Or why is the grass green? Or, why are there stars in the sky? Or, any kind of amazing question that a kid asks. Oh, I don't know. I don't know the answer. Figure it out yourself. Or stop exploring, stop experimenting. So we're born with these creative ideas, and we're born with wanting to know and being curious, and our society drives it out of us. It drives the creativity and it drives the curiosity out of us. And science is all about that. So it's about kind of being, a lot of people have said I'm a scientist. I'm kind of like a kid that's never grown up. And science is really important for our society. So you're like, okay, you're talking all this stuff, Dan, about, being creative, but, who cares? I care about finances and the economy. Well, guess what? The economy depends on science and engineering. Science, technology, engineering, mathematics is what drives economies. And it's what makes better economies, being innovative. And our 21st century success depends on our population's ability in STEM. There have been studies that show that there are correlations between our achievement in STEM education and how well our society does and how well our economy does. Sadly, the US is ranked below average on STEM on many benchmark educational exams and studies. And also citizens are just not pursuing STEM careers. And there's brain drains where people that do want to study, they end up going to other countries, or they come here and study and then they leave because those opportunities aren't here for them. So another quote, and I think this is the last quote that I'll actually give. And this is from Marshall McLuhan. And he says that our age of anxiety is in great part the result of trying to do today's job with yesterday's tools and yesterday's concepts. And a lot of what education does today is still based off of that. Sit down, be quiet, don't ask questions, don't be creative, don't be curious, and all of these things, collaboration, problem solving, communicating, reasoning, creativity, curiosity. This is what creates movers and shakers of tomorrow. This is what science thrives on too. It's how to think, not what to think. So these are things that we should be cultivating, not driving out of, people. And this is also important for science education too. Some solutions to this do exist, and a lot of people are trying to change things. For example, we have the Next Generation Science Standards, or NGSS. It's an inquiry-based science standards, which is pretty great, and a lot of schools and teachers are adopting it. Inquiry-based, project-based science. This is something that can allow you to do that. I did some of this when I was teaching. This is actually a picture of me with my students back in 2019 at MIT Academy in Vallejo. So hopefully some of those students are listening. We'll listen to this one day. Hello, how are you? And we did a modeling instruction activity. What's modeling instruction? Well, this is like an inquiry-based thing. And there's going to be, again, links that are going to be shared with you so you can explore this if you're a teacher or you're just interested, or you're a student, you're interested. But this is a way that we can do this inquiry-based science to learn how to think, not what to think. It's going through the process of how a scientist actually works. And I noticed that when I did this, it's less of a teacher talking and instructing and you spending 45 minutes, basically the exact opposite of what's happening right now, me just talking. It's you being involved and you discovering with groups and making discoveries with other people and collecting data and then arguing with each other on whose hypothesis is the best based off their data, like what a scientist does. And what I noticed is whenever I did this, students got really excited, and kids that were not, as engaged in the class before were getting engaged. And there's a lot of teachers that follow this pedagogy called modeling instruction. And there's other inquiry-based science teaching methodologies out there that teachers do that are great. But this is just one example that works with NGSS. And a lot of people use other inquiry-based science methods. Project-based learning is another thing that's great. Project-based learning is where students, they learn by doing a project. When you're in a job, like you're creating things and you're making things and you're doing, you're trying to, actually do something tangible with your work, right? So and you learn a bunch when you do that. You learn by doing. So why don't we do that in schools more? This is an example of how I learned or taught my students how to learn about electricity and circuits, where they built a model. They built a model, whatever they wanted. This was the Louvre in Paris, where they had to build the circuits and construct this model, do a floor plan, and make sure it was all to scale. And kids got super excited about that. And it was one of their favorite projects. It's project-based learning. Comes back to, all of this stuff that I said earlier from this quote. It's about working with others, being creative, trying to solve problems, and works with, some of the really good inquiry-based science stuff that's going on. Okay. All right, so I'm going to come off the soapbox of science education and tell you about citizen science. Well, what is that? There's a really good video by, I think, Hank Green on citizen science, where I got some of these ideas from to kind of synthesize them together. I recommend you watch it. There's, I think, going to be a link to that for you too. But basically what it is connecting professional scientists to average citizens. Anybody that wants to get involved. You can collect data, you can analyze data. Sometimes you can even collaborate with the professional scientists and publish. Some people might call this crowdsourced research. There's a field guide to citizen science. Actually, I haven't read this book, but I saw it on Amazon. I thought I might pick it up. It looks interesting. And there's a lot of teachers that are exploring how to do citizen science in the classroom. For example, this picture of the beach, there's this example, I think, in one of the links where students go clean up a beach in order to categorize waste, to share with the scientists, environmental scientists and ecologists. They're trying to understand, climate change and human impact, on wildlife and our environment. There's citizen science paleontology program with shark teeth. This teacher, I think it's Rachel was her name. She found the students that she had found a shark tooth from a species that wasn't supposed to be in that area. And they shared that with the professional scientists. And that was real exciting because students, they work together on these projects, project-based learning, and they're doing real science. It's more motivating. There's actually a lot of research to show that when students are involved in something that's real and meaningful and is making an impact, they're more motivated. So make sure you check some of those links out regarding this if you're curious of knowing more. How about citizen science and astronomy? Well, there's been a lot of that. And there's an exciting one that SETI did that a lot of you that are SETI enthusiasts will probably be familiar with. In fact, I had this on my computer, SETI at home. It was like a background screensaver that use your computer's processing power in order to help analyze data from, I think it was from the Arecibo telescope, I think, to try to search for life, extraterrestrial intelligence signals. So it was, crowdsourcing, processing power in order to, look for things. But there's a lot of other really cool citizen science astronomy projects out there. The American Association of Variable Star Observers does a lot of cool citizen science stuff. Zooniverse is one that's very popular that a lot of you might have heard of. If you haven't, it allows you to go on and look at pictures of galaxies in Galaxy Zoo to help categorize them. A lot of really great research has came out of this. You can go look at pictures of galaxies and help determine what types of galaxies are out there. There's also this Planet Hunters one where you can look at those light curves that I taught you about earlier and try to pick out light curves that could actually be these planets instead of other things that could transit stars. There's an asteroid one from the International Astronomical Search Collaboration, IASC. So you can do citizen science with asteroids. So a lot of cool stuff out there in citizen science astronomy for you to get involved. Some links to those will come your way too. I've talked to some science educators and I thought about this myself too. Difference between getting pretty images and doing science. Science educators are always going to encourage the adoption of inquiry-based science teaching practices, kind of like I talked about earlier. Learning science should involve claim evidence reasoning, CER. A lot of teachers might know this, science teachers. You want to make a claim and you want to support that with evidence and then have some reasoning to explain it. I would add in there wonder too, because you want to be curious. You want to wonder about what's out there, wonder about life elsewhere and, keep those curiosities alive. So before I go to the next slide, so with these citizen science projects, I hope that we can try to, make them a little bit more integrated into the science curriculum. And a lot of teachers are doing a great job with these projects, citizen science things. And that's something I'm trying to do with the EVscopes, which is what I'm about to get to. So that telescope that I talked to you about a little bit earlier, the Unistellar EVscope, they have a partnership with the SETI Institute to create these citizen science initiatives. And there's a whole network of citizen scientists. And I think maybe some of them are watching. Hello, if you're watching Unistellar Citizen Scientists. And what will happen is professional scientists will create targets for the network, send it out to observers, and then they'll take their Unistellar EVscopes in their backyard, take their backpack and go observe. And some of the things they can observe are, I'm going to show you actually pictures instead. Better to show pictures than to show text. Asteroids. So here's a graphic of an asteroid flying across the screen. And this was taken from a unistellar telescope from one of our citizen scientists. And that streak is an asteroid. So you can try to understand the asteroids and their trajectories and will one impact Earth one day and wipe out a city or a country or make us extinct like the dinosaurs. We don't want that to happen. So you can be involved in citizen science projects like this. Tim Russ, who you might have seen in Star Trek before, or some other movies. He's actually a citizen scientist with Unistellar, and he actually used it to look at a supernova, exploding stars. So you actually observed an exploding star. And we can also use these EVscopes to detect exoplanets. One of the groups I work with in my research with the Global Hands-On Universe, Carl Pennypacker and Colleen McGowan Romanowicz as GWIZ Astronomy Group. And GWIZ Astronomy Group is a group of students and teachers all around the world. We have teachers and students in the US, but also in Chile, in Africa, in Europe, in Nepal, and Asia, and Australia, and probably other places that I'm not thinking of. And these students get together every week or two. It started during the pandemic to try to connect these students to astronomy. And they use telescopes like the LCO, the Las Cumbres Observatory. And then sometimes I come on and talk to them and get ideas, and we talk about astronomy. And they were talking about looking at this exoplanet called HD 189733b. And they were going to use the Las Cumbres Observatory to observe it. And I was like, okay, that's cool. I think I'm going to have our Unistellar citizen scientists also look at this exoplanet. And maybe we can compare our data and, see if we can learn something from that. Unfortunately, they weren't able to get the time on the telescope just because there were scheduling problems. But we had 3 observers in Europe using the Unistellar EVscope. So 3 different observers. And we were able to have that data processed by our awesome whiz of data processing, Tom Esposito, and his team. And they created this light curve, transit light curve. So that dip in that graph is the presence of a giant exoplanet orbiting this star. So this small telescope can observe exoplanets. Pretty exciting thing. Oh, I needed to mention before I tell you this next thing is that some of these teachers I was involved with, we started a GoFundMe, and I think I might have had a link for that too. We're trying to raise money to put these telescopes into their hands. If you're a big benefactor and you want to help some teachers get a telescope, check out that GoFundMe. So what I'd like to do, and what we're trying to do, is to get students and teachers around the world to collaborate with each other around the planet to learn and to do science to learn science by doing science. And hopefully using some of these EVscopes to do so, just because they're so easy to use and they're portable. We're exploring grants to place them into schools so that we could have this student-driven, inquiry-based, and project-based curriculum that we're developing put into place. So with this, we're trying to combine modeling instruction, astronomy, science project-based, citizen science learning, and these EVscopes all together. Students would be treated as like equals and professionals in the process. They'll confirm NASA TESS exoplanet. So TESS is that professional telescope in space right now looking at exoplanets. Some cases, teachers and students might even publish their own work, such as in the JAAVSO, which is a junior academic journal, or others. Empower young women and men from diverse and underserved backgrounds to enter STEM. So that's what I hope to do with my PhD project. About to polish this talk off and take some questions, but just think like 2 quick things here to finish up is, well, how can you get involved at home? You don't need a Unistellar EVscope or a fancy telescope. If you want to get involved in astronomy and learning about our universe, just look up. That's the first thing. Connect with the universe. Go outside, turn your phone off, and go look at the sky. Go camping or something and try to connect with nature, or use your phone and use an astronomy app. There's a lot of great astronomy apps that can help you find the constellations in the sky. Get a cheap pair of binoculars. You can get low cost pair of binoculars, or maybe check one of those social media things where you can buy a cheap pair from somebody. Those are great to get started with. There's also local and regional astronomy groups of amateur astronomers that have really awesome telescopes that would love for you to look through their telescopes and do virtual and in-person star parties once those are safe. One example is with the Astronomical Society of the Pacific, ASP. They do a lot of connections. There's a link for that going to come to you too. And if you want to, try LCO and the Harvard Micro Observatory, request images and find exoplanets. They have great ways to analyze data on there too. You can try that out. So there's a lot of links coming your way if you're interested in getting involved with this at home. All right, to cap this off, exploration. This is in our nature. This is from a Carl Sagan. This is a Carl Sagan quote. He's one of my idols. He said, "It's in our nature. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean. We are ready at last to set sail for the stars." All right, that's it. Thank you so much. If you are interested in getting involved in this PhD research project I'm in, there is a bit.ly, which I believe that link will come to you too, bit.ly/SITSci Astro Unistellar. So fill that out, add your info, and we'll be in touch. Maybe we can do some cool stuff together. All right, that's it. Thank you so much, everybody. I think we're going to come back for maybe some questions if there's time.
Thank you so much, Dan. That was so informative and so interesting. Just so exciting to hear about the citizen science that's happening in classrooms. I know that a lot of our students at Chabot will be interested to hear more about that and learn more about that and doing some of that on their own too. And I'm sure there's lots of teachers watching who would be interested to learn more about how to get one of those telescopes. And hopefully that GoFundMe will be successful. It's just exciting to know that there's ways that teachers can get a hold of these amazing technology resources. So thank you so much.
Yeah, no problem.
Yeah, so we had a couple questions come in. One of them was, with the current technology, beyond earlier when you were talking about the Hubble telescopes and the Kepler telescopes, how far to the end of our universe are these able to see? Do you know? They're not talking about the expanding bubble of our universe.
Well, I mean, with some of the images that Hubble is taking, I mean, you're literally looking back to almost the beginning of the universe, and some telescopes don't collect visual light like we see the visible light of the electromagnetic spectrum, but there's X-rays, there's radio waves, there's infrared, and astronomers have these detectors where they can actually detect something called the cosmic microwave background radiation. In fact, this light is actually hitting you in the face right now. And sometimes when you tune an old radio or an old television set, that static, I think might even have some of that signal from that light. That is actually light from the Big Bang itself, from literally the beginning of the universe, some 14 billion years ago. So with our telescopes, we can almost look back to the very, very beginning of the universe itself.
Wow, that's amazing.
Yeah, basically when you're using a telescope, you're looking back in time. So I'm a big sci-fi fan, and one of my favorite movies is Back to the Future, the DeLorean that travels through time. And if you don't have a DeLorean that travels 88 miles per hour, you can get a telescope and actually look back in time by looking at that light that has traveled through the universe. Because every time you look at those stars, you're looking back into time, because light takes time in order to reach us from its place that you were looking at from.
Absolutely. There's some questions that have come in about doing citizen science in other parts of actually teams from India, and they're wondering if they can participate.
Of course, yeah. So I mean, I think anybody around the world that wants to get involved in citizen science, There are some links to different sites that can allow you to explore different projects for citizen science. They don't have to be astronomy. There's a lot of great citizen science in biology and chemistry, where you can go to, I think was it Citizen Sci Starters might have been one of the links. I can't remember, but I know there's a link where it's like it's almost like a Google search of citizen science projects that you can go and search for them. You could also contact your local universities in India and try to reach out to some of the scientists that work there and ask, is there any way that I can get my students involved in a project? If you want to do some astronomy citizen science, you can go through some of the links that are going to be shared with you, such as the Zooniverse, or you can even access these global telescopes such as LCO or the Harvard Micro Observatory. These are free and accessible by anybody in the world, I believe. So I believe you should be able to access those and get your own images for you and your students.
Well, thank you so much, Dan. I really appreciate you taking the time to speak with us today. It looks like that's all the questions for now. I just put the link to the form that you were talking about in the chat. So I want folks to be able to see that. And we've also included a lot of the other links that you were talking about today. A lot of really great feedback and just really interesting, informative information. Just really exciting to hear about the education that's happening with our schools through Unistellar. So thank you again for joining us tonight. And we've all learned so much, and we're just looking forward to the next time that we can get together with SETI Institute. Thank you so much to the SETI Institute for these wonderful and engaging talks. And as you all know, the SETI Institute and Chabot Space and Science Center are both nonprofit organizations. And during this time, we appreciate your support more than ever. So please consider making a donation to the SETI Institute at SETI.org and to Chabot Space and Science Center at ChabotSpace.org. Thank you all so much, and we look forward to seeing you next time. Thank you again.